Just e-learning platform Gradeup. How are you? Everyone, just respond. Everything is fine. Audio, video, Safina Khan, good evening. EC engineers, hello. Komal Gaikwad, good evening. Just e-learning platform Gradeup. Okay. Amruta, Rohan, everyone. So guys, in this particular session, we have already discussed the two sessions we have taken. Or in this particular session, we are going to discuss about the Routh Hurwitz. Previously, we have discussed the time domain analysis. So, okay, now we are starting the session. But before going to start the session, it is just a brief idea about myself. My name is Chandan Jha, 10 plus years of teaching experience. I have cracked the ISRO exam. I have done my masters into the communication and networks. Rohan, Pranam, Namaskar. MTech in communication and network. Apart from the teaching, I am also taking the motivational session. I have all right. And area of expert subject digital circuit. Already I have taken so many class of the digital electronics in this particular channel. Signal and system also I have taken already. And now it's time to discuss about the control system. Right? After that, we'll discuss about the communication also. This is the course already we know that highly recommended course for the second year student, that is Vision 2022, in which the 850 plus hours of live classes, more than 8,000 questions we will discuss into the class, 100 or more than 100 mock tests, 120 plus chapter wise study notes will provide you. Okay, these are the faculty of EC which is going to take care of this particular series. Ankit Joshi sir, Rakesh Talreja sir, Sanjay Rathi sir, MN Ramesh sir, me Chandan Jha and Chaitanya Reddy sir. Good evening Manju, Annapurna, Jatin, Rohini. Good evening. These are the result guys. Okay. One thing more, this is all about the Gradeup Super. Gradeup Super is just a subscription model. If you take the Gradeup Super, you are able to access all the live course which is going on, right? And apart from this, you are able to access the green card also. Sir, I am wishing in the tomorrow's session and waiting the okay, my Annapurna. Okay. Now guys, we are starting. Already have given this question as a homework. A few people responded in the comment box of the answer of this particular question. And now again, I want to solve this question. Everybody just give me the answer. How many of you have solved this question? Sir, for a second order system, overshoot equal to 12%, settling time equal to 0.6 second. So percentage overshoot is also given, settling time is also given. You have to find out the location of pole. How we can find out the location of pole? Everyone, if you want to find out the location of pole of the second order system, it is called minus zeta omega n plus minus j omega n root of 1 minus zeta square. This is called like this, right? I don't know why only 18 or 20 people are basically live. Tarun B, Rohan yes, Annapurna B, Mayur B. So by the percentage overshoot, we know that the formula e raised to power minus zeta pi upon root of 1 minus zeta square equal to 0.12. By this you can find out the zeta. Okay, settling time TS equal to 4 upon zeta omega n, and this TS is given what? 0.6 second. So with the help of this, zeta is also given. So with the help of this, you are able to find out the omega n also. Zeta is given, omega n is given. Just put in this equation, you can find out the answer. And the answer of this question is yes, absolutely. The B is the correct answer of this question. Right? Zeta you will get 0.56. Omega n, if you want to find out, it is called 11.9. So zeta 0.56. Omega n 11.9. And therefore the equation minus zeta omega n plus minus j omega n root of 1 minus zeta square. If you put it, you will get the answer. Yes, Niharika, absolutely correct. Now guys, the first question of the Routh Hurwitz, we already know that, but before going to discuss, everyone just give me the answer. One more question for me. Two questions I am giving you. One question in the interview question which asked to me into the interview. I will discuss that question also, but I will not give you the answer in the today's session. I'll give you in the tomorrow's session. But for that, first you have to think. So I'll discuss about the interview, some question which I have experienced. I'm going to ask that question also. But before going to this, everyone just give me the answer. Consider the Routh Hurwitz or Routh array S cube. The first row is given A, C, 10 minus k by 2 and k. In the second row, you will get second column, you will get B, D, 0, 0. In the third column, you can get 0, 0, 0. All are basically 0. where A, B, C, D are the unknown of the third order characteristic equations, which of the following option is / are correct? It is a MSQ question. It is a MSQ question. Sandeep, if you want, I will discuss the entire all about the Routh Hurwitz also, but if you want, yes, I can discuss, no issues. Okay, everyone, the 4 option A, B, C, D you have to find out, and A plus C equal to 3, B plus D equal to 15. For the system to be marginally stable, the frequency of oscillation is 5 radian per second, and for the system to be marginally stable, K equal to 10. Everyone just take the snapshot and try to solve this question. And Sandeep, I am giving you the brief idea about the Routh Hurwitz for you, right? Routh Hurwitz criteria is generally used to find out the absolute stability. To find out the absolute stability, generally the Routh Hurwitz criteria we are using, right? So, Sandeep bhai, if you want to discuss how we can find out the Routh Hurwitz criteria, so everyone try to understand. There will be this, it will take, by the example, if you want, I can solve it, right? Suppose in the one polynomial I will give you, by the Routh Hurwitz only you are able to find out how many poles will be located on the left or located on the right hand side of the j omega axis. And we know that this is the j omega axis, right? And if all the poles to be or system to be stable, all the poles should be lies onto the left hand side of the j omega axis. If any of the poles should lie on the right hand side of the j omega axis, then if any of the poles will lies on the right hand side of the j omega axis, then the system will become unstable. So by the Routh Hurwitz, you are able to find out how many poles will be located on the right hand side of the j omega axis. One thing more, Routh Hurwitz also having some limitation. Routh Hurwitz criteria is used only for those polynomial in which it has the positive real coefficient, right? Okay, so if I'm taking the one coefficient is s cube or s raised to power 4 plus 3s square plus 2s or s cube plus 2s square plus 5s plus 2. How we can solve this question, everyone? If you want to solve this question, then you have to make the one row. And you can do one thing more also, Sandeep. If you want more detail of the Routh Hurwitz, you can search into the YouTube also, right? I have taken the few sessions on this also, Routh Hurwitz. You can search it. So the maximum power you have to write here S4. After that s cube, s square, s raised to power 1, s raised to power 0. You have to write what should be the coefficient here. 1. Even power, so even power coefficient 2, even power coefficient 2. After that odd power coefficient 3, 5 and 0, like this. Now if you want to find out s square, this into this 3 into 6 minus 5 divided by 3. Fit this one 3, 6, it will give you 2, 0. This into this minus this into this divided by this factor. You have to do like this. For S1, 3 into, for this one, whatever the value you are getting, it is called 1 by 3. 1 by 3 into 5, 5 by 3 minus 3 into 2 divided by 1 by 3. After that 0, 0. And here you are getting 2. And for the stability, you have to find out the first, you have to follow the first column. And everyone, one question to you, everyone just respond. Why we are always considering only the first column in the Routh table to find out whether the system is stable or not? So Sandeep, everyone, that is the question asked to me. I am asking to you, why only the first column, not second or third column, right? Why that first column play a very crucial role into the you can say that the Routh Hurwitz criteria? Why the stability is defined only by the first column? That is my question. All right, think on it. Like this you have to solve. And how many number of sign is changed into the first column of the Routh table, that number of pole will be located on the right hand side of the j omega axis, and the system will become unstable. Sandeep, one thing more, that will be the simple condition. Now there will be the few condition also, when odd row will become 0, when one element in the first column will become in the first column, if any element will become 0, then how we can solve? So there will be the different cases, right? But it will take a lots of time for me. and this is not right place or right time actually to discuss this one. Okay, so ABD has given the answer. Okay everyone, if you want to solve this question, let me solve. What should be the value? So Routh Hurwitz, we know that this one is the condition by which we can find out the Routh Hurwitz. Already it is given 10 minus k by 2, right? Okay. So everyone try to understand. If you want to solve it, here you are getting A, B, C, D is given. So if you want to write sir A, B, 0, C, D, so you can write BC minus AD upon C and it is 0 and here you are getting D. So you can compare also guys by the coefficient D you are getting K and you will get BC minus AD upon C is nothing, it is just a 10 minus K divided by 2. 10 minus K divided by 2. So if you will compare it, you are getting K is nothing, it is just a 10 and K equal to 10 for which the odd row will become 0. And whenever the any odd row will become 0, then it may be possible the above the equation will be the always auxiliary. You have to form the auxiliary equation, differentiate the auxiliary equation, and or you can also feel the root of the auxiliary equation itself is the what pole of the system. System का ही एक pole का वो part होता है. So like that you have to do it. So we have find out sir k equal to 0. Here it will become 0. It is called 0. So we can write the auxiliary equation AS is nothing. It is just a CS square plus D is called D. Already we have note 10. And from this you can find out the poles of the system also. Right? Okay. अब एक चीज देखो, पर उससे पहले आपको कुछ और भी पता लगाना पड़ेगा. What is that? Sir, if we'll compare these two value, right? We can easily compare. What should be the value? Sir, BC value is nothing. It is just a 10 given. बहुत ही बढ़िया. C value is given, or you can write B. इधर C है. So we can write C value is 2 given. So B is nothing. It is just a 5 given. B equal to 5. Like that, if B is 5, C is 5, we know that BC minus AD, by the help of this you are able to find out the AD also. What should be the value of AD? AD equal to 10 because this self itself is the value is nothing. You can say that the 10 value is given. Okay. Now everyone, क्योंकि वो K ही बनेगा और K itself is called AD, so that is called 10. Okay. Now, so if you want to find out the A itself is called 1 and D if you want to write D is D also we can find out. This is sorry D is called 10. D is called 10 and B if you want to find out B already given 5 and A we have calculated that is the 1. So by the comparison, Naveen Kumar, hi Naveen, how are you? Okay, so if you compare it, we have calculated the A, B, we have already calculated the B value is 5, C value is 2, A value is 1 and D value is 10. So we have calculated this one. Now we know that A plus C equal to 3. Already in the problem given A plus C equal to 3. So A is the absolutely correct answer for this. बहुत बढ़िया. Sir, B plus D equal to 15. In the question you can feel B plus D equal to 15. So B is also absolutely correct answer of this question. Okay. Now system is marginally stable for the frequency root 5 radian per second. What should be the auxiliary equation? Sir, S square C S square plus D equal to 0. What should be the value of C and D we have calculated? C is called 5 and D is called 10. C is called 2 and D is called 10. 2 and 10. 2 and 10. 2 and 10. So I am writing 2 equal to 0. So we can write S square equal to minus 10 by 2 and S equal to S1 by 2 or omega n if you want to discuss directly I am writing omega and the frequency if you want to write it is nothing, it is just a what root of, because it is called minus 5 plus minus j root 5, so we can write it is nothing, it is just a root of 5 radian if plus if you will compare it. इसका मतलब नहीं d minus j, so you are also getting the j and j cancel out. Yes, omega n equal to 5 radian per second. So this is the natural frequency on which the system will oscillate. So root 5 radian per second is also correct. So C option is also correct. And system will be marginally stable for k equal to 10. Of course, it will be happen for the k equal to 10. The odd row will become 0. So D is also correct. So for this particular question, A, B, C, D, all are basically the correct answer for this. बहुत बढ़िया. Now we are moving on the next. First question clear है. Second question in front of you guys. It is called, if it is not visible to you, it is called S plus A into K S plus 1. and it is called 1 upon s plus 2, s plus 3. It is called plus minus. And guys, everyone, the condition for the system stability as per Routh Hurwitz, the first one is C3 to be positive, the second one C3 to be negative, third one is B3 to be positive, fourth one is B3 to be negative, right? Now the both 1 and 2 are correct, both 1 and 3 are correct, 2 and 3 are correct, and 3 and 4 are correct. Everyone just give me an answer. And this one is called B3, this one is called C3. That is given already in the Routh Hurwitz. You have to find out the answer. Everyone. Mayur, bahut badhiya. So Gita, that was the first question. It is the second question. And everyone, please share among all of your friends. Yaar, only 28-30 people are basically watching this series. So इस सीरीज में कोई दम रह नहीं गया ऐसा लग रहा है. Everyone, and yes, one thing more, like this session also, guys. Uday has given the answer B, बहुत बढ़िया. Mahalakshmi, after long time, B. Very Soguta has given the answer B. Divya B, Annapurna B, Uday B, Mahalakshmi B. Everyone responding for the B. Yes, बहुत ही बढ़िया. Everyone, let me solve this question. First, you have to find out the characteristic equation, or how we can find out the characteristic equation 1 plus g of s h of s equal to 0. So 1 plus g of s h of s equal to 0, you have to find out the characteristic equation, and after that, this is already given right into the question, but we have to find out, okay, but we have to find out the according to this equation, right? And if you'll compare it, or to be stable, if you want to write, if you do not compare, then also, because if compare, then A and B value we can find out, but here it is not required. Only they are asking about the C3 and B3. Everyone, sir, if the system to be stable, the first column should be, all the element of the first column should be into the same sign. Soguta, yes, Anupurna. So the first column should be into the same sign if the system to be stable. So guys, if the first is the positive here, so this one is also positive. So this one and this one both should be, all should be the positive. K is coefficient. Then only we can say that the all element in the first column should be into the same sign. Then only we can say that the system should be stable. So my dear friend, we can find positive. So B3 should be also positive. C3 should be always also positive. So B3 positive, C3 positive. So C3, both 1 and 2, C3 positive, yes. B3 positive, yes. 1 and 3 is the correct, the B is the correct option. अभी ये तो 54 भर का क्वेश्चन था. Not that much of good question. No issues. Next question. Everyone, just try to give me the answer of this question. What is that question? The first two row in the Routh table for the characteristic equation of a certain closed loop control system are given as, right, given as this. These two rows given. Now the question is the range of K for which the system to be stable. What should be the range of K for which the system to be stable? First two rows is given, and by the help of this you have to find out whether the system is stable or not. Vijay Bhaskar, hello Vijay Bhaskar, how are you? Okay, everyone, just respond for this question. बहुत ही बढ़िया, बहुत ही बढ़िया. Sir, how we can find out? S cube given, S square given, it is called 1, it is called 2k plus 3, it is called 2k, and it is called 4. Now if you want to discuss about the s raised to power 1, how we can do it? So this into this, 2k minus 4 upon 2k. According to that, you have to find out the first column should be always positive. So according to that, you have to find out the value of k for which this is positive. So if the system should be stable, we have to, this one is also positive, this one should be also positive, this one also positive. क्वेश्चन ही खत्म हो गया. यस तरुण, बहुत ही बढ़िया. Everyone, Divya has given answer A, Nidhi has given answer B. Everyone respond for this. अब तो बहुत सिंपल है ना मेरे भाई. Okay. So we have calculated the characteristic equation of the system is nothing. They have find out. We are just finding with the help of the characteristic equation also, and you can find out with the help of this also. यहाँ से ही बना सकते हो. Otherwise, they are making the characteristic equation because it is a first two order. So we can find out this equation is nothing. It is just a SQ plus 2k plus 3s, and this one is called nothing 2ks square plus 4. So this is the complete equation. If you want to write the characteristic equation also, we can write directly. That is called characteristic equation is nothing SQ plus 2k plus 3 into s plus 2k s square plus 4. That is the characteristic equation. SQ plus 2k s square plus 2k plus 3s plus 4. Now for the stability, what should we can do? Sir, inner product should be greater than the product of the outer. So 1 into 4 should be less than 2k multiplication. What should be the coefficient? 2k. What should be the coefficient? 2k plus 3. And you can also find out from here also, you can write the same thing. So we can find out equation बन गया 4k square minus 6k minus 2. If it is not visible to you, I am writing 4k square minus 6k minus 2 should be greater than 0. And from here, okay, Rohan. So if you want to write, it is a equation k minus 1 by 2 and k plus 2 should be greater than 0. So from here, if you want to write, it is called k. Here we can write 1 by 2, and the second one, if you want to write, k should be what? Greater than minus 2. So what should be the value, everyone? What should be the value for this? So we can write D, क्योंकि दोनों में से सबसे ज्यादा क्या है? एक minus 2 से बोल रहा है, एक 1 by 2 से बोल रहा है. So which one is greater, sir? This one, right? Because k should be positive also. Due to this, we can find out the k should be positive quantity also. So k should be always greater than 1 by 2. So k should be greater than 1 by 2 means greater than 0.5. So the k should be greater than, you can find 0.5 and less than infinity. D is the absolutely correct answer of this question. Yes, Soguta, note B. D is the correct answer. Srinivas, absolutely correct. Soguta, now you are correct. बहुत ही बढ़िया. निधि डी, बिल्कुल. यही छोटी छोटी सी मिस्टेक होती है जो हमको अवॉइड करना. वी हैव टू अवॉइड दिस टाइप ऑफ मिस्टेक विच एक्चुअली वी आर डूइंग, राइट? ओके. Now one more question in front of you guys. Which of the following have the greatest percentage peak overshoot? Okay. Greatest percentage peak overshoot they are asking, right? Which one having the, it means you have to find out which function out of the four, which one having the maximum percentage overshoot, greater percentage overshoot, greatest percentage overshoot. Everyone just respond for this. Again, it is a very simple question. We already know that the percentage overshoot is inversely proportional to zeta. As zeta will increase, the percentage overshoot will decrease. As we know, the graph will be like this. आपको पता ही होना चाहिए, and hope you guys already remember about this कि sir 100% percentage overshoot when zeta equal to 0. अच्छा, ये तो दिख ही नहीं रहा है. When zeta equal to 0, 100% percentage overshoot. It is for zeta equal to 0.1. It is for zeta equal to 0.5. It is for zeta equal to 0.9. It is for zeta equal to 1. This is for zeta equal to 2. So we know that when zeta increases, the percentage overshoot of the system will decrease. This is, we all are basically aware about this. कि as zeta increases, the percentage overshoot of the system will reduce for the smaller value, and maximum percentage overshoot you can achieve for the zeta equal to 0. That is 100%, right? Okay. दिव्या बी, बी बी, अन्नपूर्णा बी, बहुत ही बढ़िया, निधि बहुत ही बढ़िया, सबने आंसर दिया। सर ओनली यू हैव टू फाइंड आउट द जीटा, अ फंक्शन विच हैविंग द स्मॉलेस्ट वैल्यू ऑफ जीटा, they have the maximum percentage overshoot. So this is the characteristic equation. You have to compare this characteristic equation with s square plus 2 zeta omega n s plus omega n square equal to 0 for the everyone, and you have to find out the zeta value. You have to find out the zeta value. So if you'll solve it, the first having the zeta value 1 upon 6, second, for the second you are getting the zeta value 1 upon 20, for third you are getting the zeta value 1 upon 2, and fourth having the zeta value 5. So the minimum zeta value you are getting for the second. So second having the minimum zeta value, so maximum percentage overshoot. So B is the absolutely correct answer of this question. बहुत ही बढ़िया everyone, excellent. Now we are moving on the next everyone. Now we are moving on the next. एक और question. Everyone just give me the answer of this question. A unit step response of a second order system has the peak overshoot. MP is given, right? MP is given, peak overshoot 0.12 and peak time 0.2 second. Peak time given, peak overshoot is given. Corresponding to the frequency response, into the frequency response also, resonant peak MR and resonant frequency OHO. They have given MP, percentage overshoot, or they are given TP, time for that. And they are asking about MR, resonant, peak resonant, and they are asking about omega r. Now you have to remember what should be the value of MR. This is value 1 upon 2 zeta root of 1 minus zeta square, and resonant frequency is omega n root of 1 minus 2 zeta square. If you remember, these are the formula to find out this value. If you guys are aware about this, it means for the resonant value also and for the resonant frequency also, for those things we require zeta and omega n. How we can find out the zeta and omega n? To finding the zeta and omega n, they are given this data. You have to utilize this one to find out the zeta and omega. Dhanesh, hello dear, how are you? Okay everyone, just solve this question guys. बहुत ही बढ़िया. What should be the percentage overshoot, sir? E raised to power minus zeta pi upon root of 1 minus zeta square equal to 0.12 is given. By the help of this equation, you can find out the zeta. Okay. And peak value is given nothing. It is just a what? Peak value, if you want to write, it is called pi upon omega d. Pi upon omega d is called peak value. Pi 3.14 upon omega d is called omega n root of 1 minus zeta square. And this value already given what? 0.2. Zeta is also known from this equation. Omega n is the only unknown quantity. So by the help of this equation, you are able to find out the omega n also. यहां से जीटा आ गया, ओमेगा एन आ गया, जीटा आ गया, इसमें रख दो, you will get the MR. Omega and zeta both is known. You can put in this equation, you will get the WR, resonant frequency. Everyone just solve and give me the answer. अरे कोई नहीं बताता भाई, कोई नहीं बताता, किसी को कोई मतलब नहीं, सब मोह माया से ऊपर उठ चुके हैं. गेट ये क्या होता है? एवरीवन Dhanesh, are you solving this question or not? Everyone respond for this. Just give me the answer. Okay. If you want to solve this question, guys, already I have given peak value is given, TP is given. 90% of in the YouTube, the people are basically not watching the session with the copy and pen. They are coming only for the formality. They are just searching. There will be the one Katrina Cafe is basically dancing, so they are searching for that. और वहां पे पॉपअप आ जाता है कि कंट्रोल सिस्टम का सेशन चल रहा है, तो वो उस पर भी क्लिक कर देते हैं. फिर आते हैं, फिर बोलते हैं भाई ये तो गंदी शक्ल वाले कोई है, फिर चेंज करके फिर कैटरीना पे पहुंच जाते हैं. बहुत ही बढ़िया. रोहन बी, बहुत बढ़िया. ए एंड बी, देयर आर द टाइप ए एंड बी. नाइदर ए नॉर बी, द करेक्ट आंसर इज सी. Neither A nor B. If you solve it, then you are getting the zeta value. Everyone try to understand what should be the value. So with the help of this e raised to power minus zeta pi upon root of 1 minus zeta square, if you compare this value, you are getting zeta value 0.559, you are getting zeta value. Okay, if you'll get the zeta value 0.5599, so peak value you will get, already have given the formula 1 upon root of 1 minus zeta square. देखो 1 upon 2 root of 2 zeta root of 1 minus zeta square. Here also the same formula. You can apply the zeta value here, you are getting the MR. If you'll apply, then you are getting the MR value, right? Okay. यहाँ से MR की value भी निकल के आ जाएगी, no issues. Now if you'll get the MR value, after that, now peak value, how we can define? Sir, peak value pi upon omega d, we already know that. Zeta already we have calculated 0.559. So if you'll put zeta 0.559 and we can equate with 0.2, you will get omega n. On omega n, nothing, it is just a 17.78. 17.78 is the omega n. And now if you want to write the omega n root of 1 minus 2 zeta square, zeta is also known, omega n is also we have calculated, and you can get 10.88 is called what? Omega r. So omega r is also correct, 10.88. so you are getting nothing. B और C दोनों में से कोई एक होगा, और इसको सॉल्व करके बता दो बेटा क्या आंसर आ रहा है. C. So 1.07 and 10.88, that is the correct answer of this question. बहुत ही बढ़िया. Okay, one more question guys, one more question in front of you. Everyone just give me the answer of this question. It is also a very, you can say that easy question, not that tough question. What is the value of k for a unity feedback system with g of s equal to k upon s, s plus 1 to have a peak overshoot 50%? Peak overshoot is given 50% and you have to find out the value of k. Arey yaar, sir, it's a very easy. Peak overshoot 100%, and for those value you have to find out the k. There will be the two methods to solve this question, right? Three methods to solve this question, but I'm going for the simplest method. Yes, Ron, बहुत बढ़िया, बहुत ही बढ़िया, Ron भाई, absolutely. Sir, how we can solve this question, everyone? Sir, first I am writing the characteristic equation of this signal. 1 plus g of s h of s equal to 0. So if you want to write, I am writing k upon s, s plus 1 equal to 0, s square plus s plus k equal to 0. Okay. Now if you'll compare it with the s square, everyone, if you'll compare with the s square plus 2 zeta omega ns plus omega n square equal to 0, so we will get omega n equal to root of k. So k is nothing, it is just a omega n square. K is nothing, it is just a omega n square. Very simple. Okay. Now we already know that 2 zeta omega n equal to 1. If you know the zeta value, we can directly get the omega n. How we can get the zeta value? Sir, percentage overshoot is given. So what should be the formula? E raised to power minus zeta pi upon root of 1 minus zeta square equal to percentage overshoot 0.5 is given. With the help of this, you are able to find out the zeta. If you know the zeta, just put here zeta and you will get the omega n, and the square of that omega n value is k. So you can solve it. देखो, इसको solve करोगे zeta मिलेगा. And if you know the zeta, just put in this equation. So you will get the omega n. If you know the omega n, that square of the omega n itself is called k. That is the question asked into the question. So if you solve this question, it's a very simple and straightforward. It is a simple question. You can find out the k is 2.60. B, not 2.60. We get not, it is the wrong. Zeta, everyone just respond. What should be the zeta? You are getting 0.31. What value you are getting? Nidhi? Answer is B. The approach is wrong. This answer is wrong. B is called 0. I think B 0.53, 5.3. 5.3 is the correct answer. B is the correct answer. बहुत ही बढ़िया. 5.3 is the correct answer of this question. बहुत ही बढ़िया. Okay, now we are moving on the next. 5.3 come. Yes, Chaitanya Reddy. बहुत बढ़िया. Okay. Now if we'll solve the next question, everyone, just give me the answer of this question. So the transfer function of the second order system, the yield a 15% overshoot and peak time is 0.7 second. You have to find out the equation system of the, or transfer function of the system. In the question they have given overshoot and they have given peak time. It means they have given MP e raised to power minus zeta pi upon root of 1 minus zeta square. They have given 0.15 and they have given the peak value TP, that is called pi upon omega d. It is called 0.7. So everyone just give me the answer. And what should be the equation? No. Annapurna. Okay, Annapurna. 0.215. Zeta. Okay. Zeta 0.215. Okay, Nidhi. Thank you, Rohan, Nidhi, Annapurna or Dhanesh. Thank you. So if zeta is given, omega n is given, we already know that how we can find out the system value. Sir, everyone. Omega n, sir, second order system, omega n square upon s square plus 2 zeta omega ns plus omega n square. Because k value is not given, so I am writing the unity. You can see that the gain I am just taking as a unity. So by the help of this, you are able to find out the omega n because it is called pi upon omega n root of 1 minus zeta square. From this equation, you will get the zeta. And if you put the zeta here, you are getting the omega n. So zeta is also known quantity. From this equation, you can get zeta. From this equation, you will get omega n. Just put zeta and omega n in this particular value and you will get. So everyone just respond. Jaya Nidhi has C. Jaya has given the answer C. Jaya Sai. Everyone. Jaya Sai has given the answer C. बहुत बढ़िया. Everyone. जल्दी से रिस्पॉन्स कर दो यार. बहुत ही सिंपल सा क्वेश्चन है ये तो. Oh, very simple question, everyone. Rohan also has given the answer 3C. First is capital C and the second two value is small c. Nidhi also has given the answer C. बहुत ही बढ़िया. So let me solve this question. What should be the yes? Absolutely C. What we have given the answer? The same thing. From e raised to power minus zeta pi root of 1 upon zeta. E raised to power minus zeta pi upon root of 1 minus zeta square. We have to equate with 0.15 and you can find out the value of zeta. Okay. Yes, correct. बहुत ही बढ़िया. सबने सही दिया यार, कोई दिक्कत ही नहीं है इसमें. So you will get the C answer absolutely correct. Komal, Divya, Annapurna, Kailash, Srinath, शिवा, चैतन्य रेड्डी. यार चैतन्य रेड्डी सर, आप सर तो नहीं है और स्टूडेंट? चैतन्य रेड्डी सर. ओके. Okay, one more question guys, one more question in front of you, everyone. Okay, everyone just give me the answer of this question. बहुत ही बढ़िया. A unity feedback system has the open loop transfer function g of s equal to 25. Faculty, oh, Chaitanya sir, how are you? Everyone. Chaitanya sir is also, whose faculty of photo we have seen. The Chaitanya sir also in front of us. Everyone, say hi to Chaitanya sir. Everyone, say hi to Chaitanya sir. And Chaitanya sir, welcome to our session. Okay. A great faculty of EMFT, communication. Excellent faculty of communication and EMFT. Chaitanya Reddy sir, in front of us sir, everyone. Okay. Everyone just try to solve this question. A unity feedback system has the open loop transfer function g of s equal to 25 upon s plus 6. The peak overshoot in the step response of the system is approximately equal to 5%, 10%, 15% and 20%. And everyone, you can watch in the Chaitanya sir also right now taking the class of the communication to the app in free series. Excellent question of MSQ or NAT, or you can say that MCQ question is taking. So you guys can watch the sir session of the EMFT and the communication session in the YouTube, into the app also. So if you haven't downloaded the app, please download the app for the Chandan Jha Sir, and you can enjoy his class. Excellent class is going on, right? So everyone, just give me the answer of this question. The peak overshoot in the step input of the system is approximately equal to 5%, 10%, 15% and 20%. Everyone just respond. Okay. B, Rohan, Komal, Annapurna has given the answer B. बहुत बढ़िया देखो. Sir, how we can solve this question? Very straightforward question, not that much of tough, right? देखो, a unity feedback system has the open loop transfer function given. The peak overshoot in the step response of the system is approximate. Unity feedback open loop transfer function is given. So you have to find out the characteristic equation 1 plus g of s, h of s equal to 0. So you can find 1 plus 25 upon s plus 6 equal to 0. You can find s square plus 6s plus 25 equal to 0. You can compare this equation with s square plus 2 zeta omega n, s plus omega n square equal to 0. You can find out the here omega n equal to 5, and you can find out 2 zeta omega n, 2 zeta omega n equal to 6. So zeta equal to 3 upon 5. So zeta is also given. If the zeta is given, so percentage overshoot e raised to power minus zeta pi upon root of 1 minus zeta square into 100. You have to use this formula, and if you use this formula, you will get the answer B, 10%. बहुत ही बढ़िया, 10% B is the absolutely correct answer of this question. Excellent everyone. Kundan, Kumar. Exactly. बहुत बढ़िया Kundan, बहुत बढ़िया. Now I am asking one more question to you. A system has a 30% overshoot and setting time 5 seconds. For a unit step input, the resonant peak of the system is. The resonant peak of the system is. You have to find out the resonant peak of this particular system. Everyone. Okay, Rohan, Harsha, that's great. Okay. A system has a 30% overshoot and the settling time is of 5 seconds. So how we can find out? And always the settling time is 5. Whenever the error band is not mentioned in the problem, then by default we have to consider the 2% error. So this 5 second settling band, that is for 2% error. So 4 upon zeta omega n 5. And the system has 30% overshoot. So 30% overshoot means what? E raised to power minus zeta pi upon root of 1 minus zeta square equal to 0.13. And the resonant peak of the system you have to find out, MR. MR is 1 upon, not required for this. Directly by the help of this you are able to find out. Zeta you can find out by this equation. And if you find out the zeta, the formula is 2 zeta root of 1 upon 1 minus zeta square is called MR, resonant peak. सिर्फ zeta चाहिए होता बेटा resonant peak के लिए. Only it's required zeta, do not require mn. So even this value is not given. Even the settling time they will not mention, then also you are able to solve this question. Thank you Chandan Jha Sir, thank you very much. Thank you for your wonderful word. Okay everyone. Yes. So if you solve this question, you are getting approximately, yes Ron, your answer is absolutely correct. 1.4965, that is approximately 1.5. Your answer is correct because peak value is given. So everyone, do not go for this method. Directly you can find out the zeta. There will be several technique by which you can find out the zeta, but I am going to solve only by the peak value, right? E raised to power minus zeta pi upon root of 1 minus zeta square. You can equate with 0.3, and with the help of this you are able to find out the zeta. If you know the zeta, the resonant peak formula is 1 upon 2 zeta root of 1 minus zeta square. If you put it, you will get the answer 1.5 approximately. Nidhi, Divya, Kundan, Rohan, bahut badhiya. Now one more question in front of you guys. Everyone just give me the answer. It is also MSQ question. It is also MSQ question. Multiple answer may possible. It is a Routh Hurwitz question. The characteristic equation of the system is s raised to power 6 plus 3s raised to power 5 plus 4s raised to power 4 plus 6s cube plus 5s square plus 3s plus 2 equal to 0. The poles of the system will be A option plus J1, B option minus J1, C option -1, D option -2. Everyone just give me the answer. Everyone just give me the answer of this question. This will be the case 3. We can say that a person who have studied the control system, right? You know that whenever the odd row will become 0, that is the case of that. Odd row will become 0, and whenever the odd row will become 0, we have to find out, or we have to make the auxiliary equation just above the odd row. That is the pure even power equation, and that is the beauty of the pure even equation is the pure even equations having the root always symmetric with respect to origin. Always symmetric with respect to origin. That's the beauty. That's why it may possible the system will become marginally stable. So it may possible A and B may be the answer. Everyone just solve this question. Fundamental question, but only those people are able to solve this question who has the idea about the Routh Hurwitz, complete idea about the Routh Hurwitz. जिसको नहीं पता वो MSQ के नाम से ही देखो 10 लोग 10 people already leave the session just by the heading of MSQ. अपने से नहीं हो पाएगा सर, और फिर कॉन्फिडेंस रखते हैं कि सूर्य दुनिया में आग लगा देंगे सर, माचिस और लाइटर दे दो, राइट? ओके एवरीवन, how we can solve this question? Okay, should I give this question as a homework? Everyone, okay, 2 questions I am giving as a homework. We'll solve that question tomorrow. Just take this question as a homework. This is the 1 question, right? So that you will get the more time to solve this question. I know that this question is time consuming because 2 things we have to do. No, Rohan, think one more time. You will get the D also. Just take this question as your homework. Just take the snapshot, everyone. And if you solve this question, just write the answer of this question into the comment box also. Right later on. Nidhi, one more time. Try to solve this question. Okay, right. Okay. So just take the snapshot. Okay. One more question is this. Just take the homework question of this. The open loop transfer function of the system is g of s h of s equal to k s plus 1 upon sq plus b s square plus 3s plus 1. The system will oscillate at the frequency of 2 radian per second. The system will oscillate at the frequency of 2 radian per second. Which are correct? It is also MSQ question. 2 questions I have given as a homework to the MSQ. Okay. Yes, all are roots. You will get the C or D option after the dividing. Note in this. After the dividing you will get. Right. So just take this question also as a homework question, and you have to write the answer of this question into the comment box, and we'll solve these 2 questions tomorrow on this channel on the next session, that is 9:30. Till that, thank you very much. All the very best. And once if you are new, just subscribe this channel. And one thing more, everyone, I just want to share some more information also. We have a dedicated channel for the electrical and electronics also, right? That is electrical EC, or we can say that Gradeup ECE Impulse, and those channel are the basically dedicated channel for the electrical and electronics, right? So lots of exciting thing, and the series you can say that is going on that particular channel. So if you are from EC and E, you can join that channel also and get benefited, and that is the free series. CO, computer organization, that is the newly added topic into the gate syllabus, is also going on at the 8 AM morning on that channel, so you can join, right? Till that, thank you very much. All the very best. Kundan Kumar, sir, for ECE, what fee structure? Kundan, there is no fee structure. There will be the subscription model. Subscription model means if you will take the subscription, you are able to access not only the one course, you are able to access all the live courses which is going on, right? So till that, thank you very much. All the very best. Prep smart, be safe. Congrats. Thank you guys. Thank you. यहाँ नहीं लिखना रोहन, कमेंट बॉक्स में लिखना बेटा. Everyone, you have to write the answer into the comment box. Sai Puneet, communication.